this whole time.
Oh, really? Okay.
Yeah, but I can edit it before I post it, so they won't hear our conversation. Wink, wink. Before.
Okay. They'll hear that though. They'll just have to guess. This is what we have so far, and we could go back over this more later. But I just had it open. So we could start out by doing some simple stuff, just making a simple part. I'll try and go through that kind of quick because it's not very complicated. It's not, if people have questions, they could ask, but it's pretty simple. Okay. First thing we'll do, we'll make an aluminum extrusion. And I could pull up a picture of an aluminum extrusion. So, oh, there's something here I have to drag. I'll just do a generic one, whichever I find.
That one looks good.
Yeah. Doesn't really give much. This one, better. It's good enough. Okay.
Oh, this is the 5mm one.
Yes. Oh boy. Let's see if my computer can handle all this. Okay. So we can just, we're already in a sketch here. We could start out by just making a shape.
What are you trying to do?
Just making the cross section of the aluminum extrusion.
Okay.
So we could extrude it to be a part.
Oh, okay. So you're making the initial like dimension sketch, and then we can just.
Yeah.
Oh, that makes sense.
So really, I'm just going to draw the shape and then dimension it roughly so it doesn't take too much time.
Mm-hmm. And you would have to base this off of the specific extrusion you choose.
Yes. So this is just a generic one. It's not the one we use. I already made one for the one we were planning on using. So these lines, I'm going to make them parallel because they're parallel here. You could do that. Just control click both of them. Come in here, click parallel. It's done. And then let's see what these dimensions are. This thing, 7.5. It doesn't say what. I'm just going to do millimeters. That's what I'm assuming it is. This right here.
That's millimeters. It is.
Yeah. From here to here, I'll do 8 millimeters. And then this is a square in here. They're both 8. So what I can just do is come in here, click all these, and make them all equal in length.
Is Solidworks pretty similar to Fusion 360?
Yeah, they're pretty similar. Oh, I clicked the wrong thing. If you do something wrong, you could just delete it right here. I don't think Fusion 360 has a lot of these options where you could just like, it's like, I don't want to undo what I did. Where you could just like come in and make everything parallel if you wanted to and stuff like that.
There's a way to find stuff like that, but you don't really, you don't have to, but yeah, it's good to.
Yeah.
You can dimension their angles too,
So like,
in case if you needed to. But you should go to that one website, framing extrusions.
framing extrusions.
Yeah, because they are.
I'll do that like after I finish this, I guess.
Okay. Yeah.
Or I could just do it like right now if you think it's better.
No, do it. Yeah, finish this. Explain. Yeah.
Okay. Yeah. I'm just doing it very roughly.
Yeah. Rough, and then he'll go back and dimension it.
So I'm assuming this is also 7.5. Oh, I already made them equal. I'm already forgetting. Do the same thing here.
Yeah, he's using those shortcuts.
Yeah. I'm just more used to doing it that way. I'm just copying all these dimensions from the thing on the left. Okay, that's already defined. Got 8 here, 5 here. These are 1.5 millimeters thick. can make these the same. Oh, I accidentally
You're
clicked
gonna
the
mirror
point.
it. Okay,
Yeah, I'm just gonna mirror it.
that's clever. That way you only have to draw it once. You know, you could have just made one of those and then mirrored it twice.
This is also 1.5. I don't see it in here, but it should be the same thickness as the rest of the things here. Oh boy. Try this over here. And then here. I can come in and make a center line between these.
Oh, is that how you do it?
I mean, there's more than one way to do it.
There's it says right there that upper edge is 3.25 millimeters away from that far corner, like in the bottom right dimension.
Oh, I see that.
Yeah,
Yeah,
you can use
I could do it like that. I didn't see that dimension. It is 3.5 from the top right here. Then that would mean that this is also going to be 3.5. Apparently not. Maybe the length of that is messed up. It's 3 points. Oh, it's 3.25. I think maybe I have this dimension somewhere. Okay. It's fine. I'll come in and start working on this.
Yeah, this thing is a highly dimensioned part, but it's really important that you get it accurate. Accurate. I can't say accurate anymore. I can't say it accurately. But yeah, it's really important that you get that right. Just that you know that how your
those are already constrained.
nuts will fit, and you know, make sure everything's of your frame is built correctly, because this is kind of the building block of your frame.
Yeah. What's that value again? Here to here.
So when we're like looking for parts, like say I want an aluminum extrusion like that, and I want it like a certain length, how would you guys make it that length?
Well, when you're ordering them, you could see like what lengths they'll sell them in like lengths of 100 millimeters difference. So you can get like 100 millimeter, 200 millimeter, 300, or there's another like, I guess company we're looking at to just get them custom made. But to do that, you have to use their extrusions, which are different than this. And after I guess I'm through with this, I can open that and show you how to use their parts.
Your dimension on the right, 3.5, it needs to be 3.25.
Yeah, it just messes things up a little bit. 3.25.
So then like should I design the the frame of it and with like the dimensions that they have like on Amazon or something?
Yeah.
Okay.
Yeah, but we'll show you. Maybe we should go to that link now. Show you that kind of website.
Do you know where that link is? I don't remember.
Yeah, it's Framing Tech. That's what they're called. You can probably just look that up.
Okay. Oh, I meant to make that 10. I'll come back to it anyways. Framing Tech?
Yeah.
Oh, these guys. Okay.
So
and then
they're a company that specializes in making aluminum extrusions. And they're based in Escondido, so that's like really close to San Diego, which is really nice.
Mm.
Yeah. And if you come in here, they have parts somewhere. Do you know where it is, Jason?
Yeah, okay, scroll to the top and then click on the 20
Okay.
millimeter with the 5 mil. We can do the 6 mil either. You can choose whether or not you want to do the 6 or 5. It's up to
Yeah.
you. That's the difference in the gap, like the size of the gap in the extrusion.
Yeah. It's the distance between these two.
Mm-hmm. So you click on the 5 mil one. So click on the top one.
Yeah.
Yeah, that one. And then
And
scroll down under documents and it'll have it. Scroll up a bit. It's no, a little bit more, and then there should be a thing documents. What's that tab at the bottom right above features? There's like a, it's not loading for some reason, but right there should be documents, or no? Oh. Oh wait. Oh, click on.
they have
no.
the dimensions
Yeah,
here.
they have the dimensions.
But
Click
they
on,
should have a silver part.
click on the millimeters thing up at the top, like for buying size. Scroll down. We're under cut to length. Yeah. Okay. For some reason, yeah. So you can get it cut to a specific length.
Yeah.
I don't know why it's not there for you.
Maybe they only have it for certain profiles.
Well, it was on that profile.
Yeah, I mean, we downloaded. I could show the one we downloaded, and then later we could like post a tutorial on how to get to them.
Yeah. Millimeters. If you do cut to length and you say like. Oh, they only have 51 available. Okay. Yeah, you can find it on their website somewhere, a download zip file. Not sure why it's not available right now.
Yeah, I don't know. What is these dimensions? Be 10 millimeters away. It's correct.
So, I'm curious, for the people in
Yeah.
here, what's your experience with 3D modeling? Do you have like any experience whatsoever, or what level are you guys at?
I have no experience at all. I mean,
All
I've
right.
used Autodesk for like 2 classes, but that's it.
Well, do you know what like the tools are, like the line tool, rectangle tool, circle tool?
Oh yeah.
Yeah, so right now we're just defining the sketch right now. So it's 2-dimensional. We're using the different tools at the top, the line tool, circle, and rectangle tool. And then you can define the values using the smart dimension tool or an Autodesk or Fusion 360 especially. They have a dimension tool, but they have a keyboard shortcut that I like to use. Just press the D key on your keyboard. Yeah, it's just called the dimension tool in Fusion 360. You know, they call it smart dimension in Solidworks, but same thing.
Yeah, it's just been a while since I've used it, so I probably need to like, what do you call it? Like get used to it again.
Yeah, it's like riding a bike.
Oops.
Yeah, this is a pretty complex geometry to model. There's a lot of dimensions on it.
There do be a lot of dimensions. Okay.
So what does the collinear thing do?
It just makes the lines basically act in the same plane. It makes it kind of like an extension of this line. They're like on the same line, kind of.
Okay, I see. So it's not like the parallel. It's like it's just straight on.
Yeah, it's like an extension of the line, kind of.
Okay.
Kind of like the same thing. Let's see.
What was that website called again?
It was called Framing Tech, and I'll let you if you
You
go
post
to
in the Discord too.
Yeah, I can post in the Discord. I definitely will, actually.
Okay, I found it.
Yeah, but you can always look at our parts list, Team Sixes, and there's a link to it on there. But let me post in the Discord right now. Of course, Discord is acting up.
Yeah. Okay. I'm just gonna mirror what I have for right now so I can move on from this. I don't want to make it actually exactly what it's supposed to be. So we could come use the mirror tool. I drew this line here so we could have a plane to mirror it around. And then I'm just gonna select all these lines to mirror.
You missed one.
I guess I did. Yeah.
So how would you edit your mirror?
I would just mirror again.
Okay, you can do that. Yeah, so you have to select the line that you're about to mirror about, and then you got to select all your entities that you're trying to mirror. And then you can start going to the 3D of it all with the extruded boss
You can
base
come
tool.
select all the parts that you want to extrude. You can
Yeah.
drag it, and then you can put a specific dimension. I'll make this 100 millimeters. That's like pretty short, but that's okay.
Yeah.
Maybe I'll make it longer. I'll go 200.
And that's the same as the extrude tool in Fusion 360.
Mm-hmm. So now we have a solid part that we can use. We could also make more sketches on it to either bring out more pieces of solid part or cut out things. So I'll show like you just come in, make another sketch on a plane here. You could use this tool to kind of reorient yourself. Come in, let's say you wanted to drill some holes. You could center some holes. I like to just go in and make them equal. That way, if I want to change things, I only have to change one dimension. It'll change both the hole sizes.
How do you get the holes to be centered on there? How do you make sure that they're centered?
I could show a way to do it in a second. Let's say we wanted to make this like 5 millimeter hole. They're already centered because I hovered over this line and had it be, it shows that little centering thing. But
Oh,
if
and
it
that.
didn't do that, then I could draw like a construction line kind of. Make sure it's like centered between these. If it's not connected to this origin, then I could come in and draw like a centered line and then use the center of that piece to draw another one to orient everything to be on the center.
Oh, so that yellow dot indicates where the center of that center line is.
Yeah, you could do that. And you could dimension these to like the edge, like 20 millimeters. And then I could dimension this based on that, like 20 millimeters. And then since I want to cut some holes, I could come in, just click extrude cut. It'll come in and try and cut them out. The default is by a certain distance. You could come in and change that to just be through everything. And you don't have to like worry about cutting behind it, cutting something you don't want to hit. There's a bunch of options here, like up to next. It's going to do just up until the next surface. So it's going to be there. It's going to stop the cut on the surface in here. There's a bunch of options. You can mess with them. But right now, we just need through all, make some holes.
Mm-hmm. Fusion 360 has some options too, but it's good to know the distance you're extruding, and keep in mind in your head like the width of these extrusions, and like this one for example is a 20 millimeter by 20 millimeter extrusion, so it's like 20 by 20 profile. That's what they call it. You can get 20 by 40 profile, which is like it kind of looks like just two of these stacked on top of each other,
like sideways.
yeah, or yeah.
So
So
like say you have like that extrusion already.
Uh-huh.
Can you assemble like a frame in
Yeah,
SolidWorks or Fusion?
I could show how to. In Fusion, the assemblies are a lot different. They don't really work as well. I could show how to do that too. But
Yeah, they're called joints in Fusion 360. You can still do every assembly, anything that you can do in SolidWorks, you can do in Fusion 360 assembly-wise. It's just a bit different.
it's kind of a pain, in my opinion. I don't really like it. But
Yeah, can I see you
yeah,
do it in SolidWorks then?
yeah, I could show how to do it in SolidWorks. I'll name this like test extrusion.
Yeah, so we're gonna kind of move kind of fast. We're just starting off showing you sketches, then making a 3D model, and then modifying it with holes, which is pretty important to know. But now we're just gonna jump into the assembly of it all.
Yeah. Okay. So to make an assembly, you click new, come in assembly, you can double click it, just click OK. And I don't really need this window right now, so I'll just make it full. It's going to start you out. It's going to give you this kind of screen. It's just asking what pieces you want to bring in. Since we had both of these pieces open in this SolidWorks like session, then it's going to have these. So I could just click one of these and it shows it right here. If you don't see the part you want, you have to click browse and select it manually. Like if I want to import any of these parts, it didn't show up here. I'd have to click them. But we just want this one. So I just come in, click this part, click right here, and it's brought it in. So obviously I need more than one part to start assembling things. So I can bring in just another one of these for now. And you can do that by just coming to assembly, insert components. I'll just bring in another one of these.
Yeah, and are you gonna personally use SolidWorks or Fusion 360 for your design?
I'm still deciding.
Okay. Yeah, I know that. I think someone.
I have Fusion 360 downloaded, but I could still download SolidWorks.
Yeah. Do you have the code? I think I sent it to you.
I think everyone has access to it.
I think you sent it somewhere.
Oh, yeah, I know one of your teammates. Doesn't he have a Mac?
I think so, yeah.
Okay.
Yeah, I think he does.
Yeah. So SolidWorks can't run on Macs because it's built for engineers.
Okay.
Yeah, I think he's just gonna stick to like doing the other stuff.
Yeah, there's a lot of stuff to do, even not assembly-wise. Just finding the right parts and links to them, making a parts list is it takes a lot of time to get everything just right. Because you only get one real shot for us to order parts for you.
Yeah.
Yeah.
So we can use this mate tool to start putting things together. You want to keep in mind how you'd put them together in real life. So like we already have some holes here. Let's say we made these holes specifically to put a screw in and put it in this part. So what I can do is I can come click one of the holes and that selects that part of that component. I can come click this hole and then the holes align pretty much is what that does. That's what this option would do. Concentric is like the holes will align. And I don't want it to face this way. I want it to face the other way. So I can just click that, faces it the other way. Now, since here, I'll tell it that that's what we wanted. Since we only constrained it by one hole, it's free to rotate still, and it's free to like move into that part. So to like completely constrain it, what we could do is like mate the faces together because that's how we want it to be when we screw it in. And in real life, if we were to just use one screw to hold this in, it would still be free to rotate, which isn't great. And we want to keep that in mind, like while we're designing our assemblies, to make sure that we don't have parts that would rotate like that. But if we came in and we like bought a bracket, which I don't have a bracket in this assembly yet, but we can imagine we have a bracket, and I could mate these two things, and that would fully define it because it's no longer able to move in any direction. You can see that because, well, I guess I'll undo. Because beforehand, we have this minus. That means it's not fully constrained. This is the first part we brought in, so it's fixed. That's why it has the F. I have to constrain it again, but that's pretty quick. To show that when it's fully constrained, it doesn't have that minus sign.
Yeah, Fusion 360's assembly file is like kind of different in some respects. Like it's not as easy with all these commands with your constraints. You gotta kind of think about
Gotta
it more.
finagle a little bit.
Yeah.
So now it doesn't have the minus. It's fully constrained. It's not going to move at all. But this is kind of like in the imaginary state where we have an invisible bracket here. That's pretty much the simple parts of the assembly. There's more complex stuff you could do with different types of mates. And I could show that by bringing in another part because it might be helpful.
So like, how would you even screw that in though? Like,
If it was threaded, then you could just like screw it in. And you could like get them
okay.
threaded from the manufacturer, I'm pretty sure.
Yeah, that's the good thing about ordering from that one company I linked down below is that they have machining capabilities. If you buy from Amazon or something like aluminum extrusions, you're just gonna get bare aluminum extrusions, no holes in it. You know, you'd have to drill them yourselves, or you know, I would have to get the a manufacturer to drill it for me. But you can just buy them already drilled.
Hmm. They
Hmm.
also sell brackets like these, and I'll just bring this in to show. Where let's say like you don't want to get it from that manufacturer.
Yeah, you just put it like on the side.
Yeah. And then there are these like special types of nuts that slide in these holes. So then you could use like these holes here
Okay.
and screw it in.
They're called T nuts
Yeah.
because these are T profile aluminum extrusions.
Yeah. So these aluminum extrusions don't fit on here because they're not like, I didn't make them the perfect size because it was just a
Mhm.
quick thing. But when you have actual like 20 by 20s, or you could even use this like the 20 by 40 if you just screw in like the outer edges here, then these things should align and you could like connect them that way. So you don't have to thread anything.
Yeah, that's it makes it cheaper for us. You know, it makes it a lot easier for keeping track of everything if you were to do something like this. But you know, just keep in mind these screws like that can loosen over time.
Yeah,
Like
they
which
really
kind?
do. The kind that you drop in the nuts for and you screw them in
Oh,
here, over time, just from like the 3D printer moving and like vibrating and stuff, it does loosen usually, but you can put like maybe some Loctite in there or something,
okay.
and that should prevent that. Another type of mate that you might find useful, and I'll bring in another part to show it. Find these. Where do we have our rails?
Assembly
Oh,
one. Okay.
yeah. So these are a type of rail you could use to have like your moving parts on, and an easy way to like get them to be centered in your extrusion. First, I'll just mate the faces because they're going to be up against each other. And then let's say you want this to kind of be in the center of this piece. You could come into like advanced mates and use a width mate, and you just select the two like tab parts or width parts, I mean, and then these two edges. And then it would kind of center it as if it was a tab.
Okay.
Yeah, this isn't the only way to do that kind of constraint, but it's
It's
just
just one way that
yeah.
is pretty quick and easy. It's still free to move in this direction. And to stop that, I could just put these faces together or mate them with a coincident mate. That means they're like up against each other. Okay.
And you said it's called a rail?
Yeah, it's called a linear rail, and you have to make
Mhm.
sure that you put this in the right way. Just for your assembly file, because the thing that rolls on it, you know, it goes in a certain way.
Mm-hmm.
Yeah, I could bring that into it's
And we
looks
grabbed
like
this
this.
model off GrabCAD.
Yeah. You can find a lot of the models you want to use off of GrabCAD, and it saves a lot of time trying to make them.
And then what if you find it on GrabCAD, but then it's like you can't find like where to get it, like on Amazon or anything?
Oh, well, you have to use stuff that you can find to put on your parts list. Otherwise, like, we can't really get them to you. So try and make sure you,
Yeah.
yeah, use parts that you can find on somewhere.
Wait, so what are you doing right now?
Oh, I was mating just these two surfaces because this is what it rides on. So I was mating those two surfaces because those are what are gonna touch.
Oh, so that's what goes up and down on the linear rail, moving up and down.
Yeah. It's still able to move in many directions because it's not constrained right yet. It can move like on the plane of the one part that I connected, and that's what you could see it doing. So I'm gonna come in. Oh, it's inside. Move it over here.
Oh, so they're parallel right now, and that's it.
Well, these faces are coincident. This one and this one here. Now I'm gonna make these other ones do the same thing. I think I clicked that corresponding face. Yeah. Now it's gonna still have the minus because it's not fully constrained. It still moves. And by the way, this thing I imported is not just one piece. It's a whole other assembly of different parts. So you can import whole assemblies into another assembly.
Mm-hmm.
And then this is how it would move in real life. So I don't mind not having it fully constrained in here.
Yeah, just something to keep in mind, those holes on the rail, what's the diameter of those holes?
Oh yeah, if you want to like check something quick like that, you can just click evaluate, measure. You can come in and click the hole, and it gives you a bunch of stuff. So area, the diameter is 3.5 millimeters.
Okay, so that means you'd have to use like an M3 screw, basically.
Yeah, the way this is meant to be mounted is you use those nuts that slide in here with the screw that comes in this side, and you just screw it into the aluminum extrusion.
Mm-hmm. But you'd have to use like an M3 screw because it's such a small hole.
Yeah.
You
Okay.
just have to make sure, the parts that the screws that everything have, the nuts, they all fit together and they all work. And we'll look at your parts list and we'll try to like catch any mistakes. But it's really up to you mostly
Yeah.
Yeah.
to catch those.
I think this is good enough for sure. Like the basics of the assembly, I think you can assemble your whole printer just using these techniques. Are you thinking of anything I'm missing, Jason, or is that good?
No, just in Fusion 360, it's called the inspect tool, but you have to make sure, move the rail all the way to the left. Make sure that things don't conflict with each other.
Yeah, because it won't like stop you, as you can see.
Mm.
Yeah, you gotta like that's the whole point of the assembly file is making sure that your design works. And can we go to our printer assembly file? All right. Show them the bed thing, like the clearance.
Do you mean clearance of the extruder?
Yeah.
Okay, so one big thing that we wanted to make sure is that our extruder can go to all corners of the bed. And that's like a really good reason to have an assembly file so we can make sure of that. So let's say we were to drag this over here. There's like a stopper on the ends of these. You can remove them, but like it's pretty much the end of how far you can go. But we want to make sure it doesn't interfere with these belts or anything else when it's at that distance. So we could see like it's already cleared the bed, and we can also see it hasn't interfered with anything, so it's fine in that direction. We kind of just visualize each different way it could move, and we were like,
Not just the extruder that needs to go over the bed. It's the nozzle. It's the really important thing is the nozzle. And if you have an
yeah,
auto leveling system, it's the auto leveling system too. It needs to make sure you can reach all four corners.
yeah. So that's like one thing that's useful about having an assembly, just to make sure everything works the way it's meant to. I could show how to route these belts.
Yeah, that might be good. Maybe not something too complicated, but
Yeah, if you're doing Core XY design, then it's probably going to be helpful to route the belts because the belts is kind of complicated in a Core XY. And you could see it here. Like these lines here are the belts.
Mm-hmm.
To do that, you can come in assembly features, and you could do a belt chain, belt/chain, I guess. And then you could come in and just click anything that has like a circular face. Even this, although it's not a circle, it knows this is curved. So if I click this, that's the start of the belt. I come in, I know the belts. I've already measured all these to work the right way. I can come in, do the other part of the belt, and then it comes around there. I think it comes to this bottom one. No, it comes to the top one. You come click that thing, and you can see it's starting to
Oh,
do the
okay.
belt already.
Yeah.
The belt gets kind of funky when it's not in the right order, and I guess I could show that. Like, actually, this is pretty close to what it's supposed to be. I guess that's just lucky, but belt doesn't really wrap around like that, so you can use these arrows to flip it, and that's actually what it's supposed to be like. But sometimes it'll you could change the order, so maybe it ended up like that, and that's not what I want. So I could change the ordering of them to be what I want instead of being something weird like this. I could do that by just clicking on the gear things here and moving the order in which they run the belt. Okay. That, using those tools, I think exclusively is how we made this entire thing. We didn't really use anything other than what I've already said.
Metal.
And then you guys just double check that like all the parts that you are in the assembly, like you could find it online and stuff.
Yeah.
And then like you guys even found the extruder. Like, did you guys like build that part by part or
No,
like?
I
Okay.
that would have taken forever and
Yeah.
not really worth it. So I just found this online. Actually, I got this part from the manufacturer. They have a model, but it's not like a Solidworks model. They have like a step file is what it's called. And when I put in like the step file into the assembly, it really doesn't work well and it causes a lot of errors and like weird stuff. So I just opened the part as a step part, which is like what is default. And I just clicked save as, and then just saved it as a SolidWorks part, so it works a lot better in here. So if you're having problems with like different file types, you could just save it as a SolidWorks part, and it should fix it.
Yeah, cause there was like some part I needed like a 3D model of, but I just couldn't find one. Like that could go into Fusion 360. But I mean, so you say you just saved it as a different kind of file?
Yeah, but the here I could show you. I could just open what it came as if I could find it. Hopefully, I know where I put it. Let's see. Okay, so this is what it came as, I think. I'll open it right now. This should be a step file. We'll see.
What part were you looking for, by the way?
I think it was one of the yeah, one of the nozzles, or what do you call it, the extruders. I don't remember what kind of. I was
It might
kind of
be,
looking
was it the
for like
arrow?
any of them. Was that?
Was it the arrow?
Oh, oops.
Hold on, let me look at my team's part list real quick.
Oh, also, if it's not showing up, like when you click the open, it might just be because you have like maybe a SolidWorks part selected and then it doesn't show up here. But if you scroll down and you click all files, then it'll show you any file.
Okay.
So like, I'll open that one.
Oh no, it wasn't extruder. It was the I was looking to just see if I could get like a grab cat of like the hotbed, but then I think I realized I could just make a rectangle or a square.
Yeah, the rectangle is probably gonna be easier.
Yeah.
It models it pretty well. You just gotta make sure you have the holes in the right place on the rectangle.
So
Yeah.
this is opened as a step file, and like when I put this into the assembly as it is, it doesn't save the assembly right, and it keeps giving like error messages. So just come in, save as, and oh, it's already saving as a SolidWorks assembly by default. So yeah, click that, and then it'll save as that instead of a step file, which is right here, and is what it came as originally. I already did that, so I'm not going to do it again because I don't need a bunch of random files.
Yeah.
Okay. There we go. Should I try and show how to do like a quick assembly in Fusion, or should I try and show how to do these sheet metal pieces?
I think the sheet metal while we're in SolidWorks though.
Okay.
Yeah, I think I'm gonna use Solidworks now.
Yeah, it's easier. I don't know. You said you could do sheet metal in Fusion, right, Jason?
Yeah, there's a tool for it at the top.
Okay. I've never tried it in there.
Sure you can figure it out. But let's do it in SolidWorks because that's
Yeah.
what you know.
So I'll just open up a new part. Just a normal part.
Front row.
No, it's fine. You know, she's taking his time. Okay. You could just start out with a normal sketch. And you kind of draw the flat version of what your sheet metal part is going to be. That's how you start it out. So I'll just make like maybe some sort of mount similar to one I've already made.
Yeah, like maybe a right angle bracket or something.
Yeah, I could do like a right angle with like a little fold maybe.
Okay. Going fancy.
Oh yeah. Okay. I'll just do this and then I'll explain what I'm doing in a second.
What are you doing?
I said I'll explain in a second, Jason. Don't you worry. Okay. I'll just give this some random dimensions. I'll make it
420.
That's really big. But okay. I'll make this one 20.
Really
I know, I don't want it to be 420. I know. I'll make it like 100. Oh, now everything's messed up. That's fine. How long is a servo motor again? 1.7 inches.
42 millimeters. It's not 1.7.
Was it 3? What?
It was 43 millimeters.
Okay, I'm glad you have that memorized. I just make this also 43 millimeters. It doesn't really need to be. This is going to be a weird looking part. Okay, and then I'm not going to make the holes right for the motor, but there are some holes that go here to mount a motor.
Well, they're just 3 millimeter holes.
I know, but I don't remember the distances between them. I don't feel like looking them up. It's going to take too long. So it looks vaguely like that.
38 millimeters.
Okay. So this tab is already here for me because I've used it, but it's not there by default. So what you have to do is right click here and you get so many options. But sheet metal is right here. And you click that. I clicked it so it went away, but usually it's not there. So you click it and it's there. Instead of using the basic like extrude, which is what we do for like normal parts, you click this and it makes a sheet metal part out of your thing. It'll just be flat for now. Oh, it's going to be 3 millimeters. Sure. I think when we order the sheet metal, it's going to be 1/8 of an inch. Am I right?
We might be able to do metric profiles to like 3 millimeters. We plan on using steel.
Yes.
Okay.
So I'll just leave it as this, 3 millimeters.
Yeah, maybe actually do 1/8 of an inch. Because I think that our supplier is probably gonna do imperial measurements, and we're all gonna have the same sheet metal like kind, because it's just easier to buy the same sheet, and then we can figure out how to cut it up efficiently between everyone's
1/8 of
part.
an inch is almost exactly 3 millimeters, so it's like it looks the same.
Yeah.
Okay. Now we have a piece of sheet metal. The way we can manipulate it is you come in here. Right now we just want to make some bends. There's a ton of options. Oh, I should have mentioned something. I could do that later. For now, we're just going to make some bends.
Yeah. You can mention it later.
So you click the bend. It's going to tell you to select the face that you want to bend. I'm going to do the only face we really have. And all you need to do is just draw where you want to make the bend. So let's say we want to bend this part. We draw a line there. And then we can exit the sketch because we've drawn our line. That's what we want. It says bend parameters. It's this face again. And it's already assumed we want a 90-degree bend. But you could see it's also bended this edge kind of weird.
Yeah.
So that's where you can come in and select the different types of bends. So like, let's say I clicked this. It would bend it here where it doesn't interfere with this edge. It's like this one still interferes. This one, it just bends on the outmost part. So this part of the edge is like the top. It's depending on what kind of bend you want. Here, I'm going to do that kind of bend. And it's 90-degree bend. You could change the radius of the bend, which is kind of important because there's like a whole guide on how to make sure you make your parts right. And the diameter of your bend is dependent on like the thickness. This is something you should refer to if you want to make sheet metal parts, just to make sure it's like possible to build.
Yeah, can you send me that link?
Yeah, there's more than one of these types of things, but I can send this one specifically, and I also recommend you look at some other ones because there might not be everything in this specific one. This is just like by a company that bends sheet metal, so this is what they want specifically.
Oh, okay.
But like, yeah, we
haven't decided on where we're gonna get our stuff manufactured.
Yeah, we've gotten quotes and we're kind of looking at different companies and seeing maybe if we could just do it in the machine shop, or we're still looking at different options basically.
Mm-hmm.
We could do another bend here. And then I just click escape to get out of the line tool. Come back here, bend parameters would be this face. Come in, and this type of bend, since it's not showing up, is probably a type of bend that wouldn't work. So say this one is one that would. That's why it shows up. Sometimes none of them show up, and it's just, I think it's a little bit of a glitch. But if you know one should work, then you can click this. And if you don't get an error message and it shows it works, then it means it works. Okay, so the intention behind folding this part was, let's say we weld it here and it's stronger. I obviously didn't measure it correctly because it would not fit, but I did that really quickly. We could edit it to make it fit correctly. There's another thing that's pretty important, and it's talked about in the guide, and it's that you don't want to have any sharp edges when you're manufacturing it. I think that's just for them when they're making it because they cut themselves on the edges. And even in like this, maybe it was another guide I looked at, I don't remember if it was this one or not, but it said by default they're just going to round the edges even if you don't tell them to, unless you specifically tell them to keep it sharp, because it's just more dangerous that way. So a tool you could use is come in and into features, and use a fillet. And you can come in, click all the edges. And this is much more rounding than we want, but I'll just edit that in a second after I click them all.
Is it just specifically like corners like that?
Yeah.
Okay.
I
So
think,
like that, like the edge of it wouldn't have to be rounded.
yeah.
Okay.
Like this edge here is fine,
Okay.
like these ones. So let's say we wanted that. We don't want it 10 millimeters. Maybe it says that the radius of your cuts should be about the same as what's it called? Like the thickness of your part. Ours was like 1/8 of an inch. 4 millimeters is like a little more than that. Just do that. And we have these. So that's like the basics of how you could use the sheet metal to make your parts. And I could show you the sheet metal parts we have. We're using a lot of sheet metal parts, and I'm probably going to get rid of them because making them is pretty expensive.
Mm-hmm.
And we didn't really know that when I designed most of them. So I'm probably going to like these parts here. We could just like manufacture them a different way, maybe 3D print them, just design them differently and do that because there's small sheet metal parts that don't really need to be sheet metal.
I think those should stay sheet metal. They're pretty important.
Why? I mean, the 3D printed part would be fine. If we 3D printed it, I could have like one part that's a right angle. Like,
Well, we don't want to encourage people to use 3D printed parts because then
that's also true. We don't want too many 3D printed parts because we can't really make them easily.
Yeah.
well, it's because like think about it. You know, like if people design their printers and like keeping in mind that they're gonna use 3D printed parts, like their whole printer is gonna be 3D printed. Basically,
Yeah.
all the corner, all the joints, everything that holds anything is all going to be 3D printed. And then there's so many of you guys. It's just like cranking out all those prints, like making sure that they're quality too. It would be kind of difficult.
Yeah.
Yeah, I got you.
I wouldn't be too afraid of doing the sheet metal because we have a budget for manufacturing stuff, but I wouldn't go overboard. Like, don't make your whole printer sheet metal. If it's needs to be sheet metal, or if it's easier to do sheet metal, I would do it. But yeah, don't do it unless you have to.
Yeah.
Yeah. Like this
So
is,
another question is like, when you guys make the 3D model and stuff, do you guys include like all the wires and all that?
We haven't gotten there yet, but we're gonna have to plan for that for sure.
we keep it in mind. We don't actually put in the models of the wires because that's just, it's kind of a lot. I personally don't think it's really necessary because as long as you have in mind where they're going to go and you have room for them, then you'll be fine. But you don't want to just leave them as an afterthought because then it'll get really messy.
Mm-hmm.
Yeah. And especially if something's moving, like a wire's moving, like for the extruder and the hot end, all those wires are gonna be moving. You definitely need to have a clear path so that they don't get stuck on anything. Like the wire like comes down and like drags on the belt or something. You definitely don't want to make sure.
Yeah.
You definitely want to make sure that there's not gonna be an issue with any of the wires.
Yeah, if wires like got caught on something and unplugged, it would just ruin the whole print. So you want to make sure you have like a clear path for them to be and just have that thought out. Especially you want to make sure you remember to leave a spot to put your electronics. Keep that in mind.
You can probably find off GrabCAD the MKS board, like a 3D model for it, and then you can either make your own power supply. You don't have to be that precise with your power supply. You can just make a rectangle.
Yeah.
Yeah, like back here we have a lot of room to put things. It's not really going to be used. This is probably where we're going to put our electronics and have the wires kind of run down the sides of these aluminum extrusions and plug into them down here.
And you can always base your design or like your planners off of someone else's 3D printer, or a company released a 3D printer. You think it's good. It's good to like base your design off some stuff that works. stuff that you've seen work.
Yeah, it definitely makes things easier. And to look to them for inspiration if you're stuck on something.
Mm-hmm. You can also use sheet metal without bending it, and that's a lot easier for us to. It's a lot cheaper.
Yeah, this part right here is like an example. This part isn't bent, but it was a mount for our old extruder that we're going to use, so it doesn't fit directly into this one yet. I have to remake it a little bit, but we don't plan on bending this piece.
Yeah, it's just 3 pieces of metal. That'll be fine.
Yeah.
And that's the Hemera extruder, by the way, and that's coming back in stocks pretty soon. So that's going to be nice for us because the Hemera is a really good extruder. It's kind of pricey, but you know, it's an investment for your printer. It's definitely an important part of your printer. Like one of the most important things is the extruder.
Yeah.
Yeah. So like I think one of the hardest parts for me was like just trying to figure out like what some of the parts are called. So like where would you find like an extensive list of like every single part?
You would go to our Google Drive. We have a couple lists there. We have our recommended parts list, and we have our Team 6 parts list. That's our team. It's like an example of a parts list.
Okay.
Yeah.
You know, you don't have to include everything that we have. You don't have to even use the same parts we did. You know, like a lot of the sizes are going to be different for you. If you have a smaller build plate, you know, we decided to go with a bigger build plate. Just because we thought we knew we can handle it. You know, this some things it's harder to make sure everything fits with a bigger build plate. You know, it's heavier, so you have to find a better way to lift it up and down. So there's a lot of things that go into it, but we think we're up to the task. You know, we always want to challenge ourselves. Are you on our Google Drive shared folder?
Yeah, it's somewhere in the Discord. I think I found it right here.
Yeah, it should
Um,
just be shared with your email. If it isn't, let me know.
yeah, I'm pretty sure.
Yeah, maybe hopped on Fusion 360.
Okay, I can do that. I don't think there's anything else we're gonna do in SolidWorks for now, right?
Stress test.
Stress test. Good. I don't know how useful it is.
Yeah, that's not.
Okay. I'll just exit out of it so my computer doesn't die.
And the reason why we decided to use linear rails is because they're just like the best for movements. You know, they're a little bit more expensive, but they will give you the less vibrations in your movements, and you can get up to faster speeds with them. You know, it's just a better kind of moving.
They're
Pair.
definitely not completely necessary. Like most printers don't use them because they just don't really need them. But we thought, why not?
High-end printers nowadays, especially coming out with just linear rails.
Yeah.
Especially for the X and Y axes, which move the most. The Z axis doesn't move that much, you know, it's just like moves up by like 1 layer height every few minutes. But your X and Y axis are going to move the most. So they're the most important when you're thinking about vibrations and fast movements. And, you know, even with the shepherd motor drivers, those are the most important ones.
Yeah. You said the Team 6 parts list?
Yeah.
Yeah, that's the parts list that we're actually using for that printer you saw.
Mm-hmm. You know, we give you a pretty big budget, like $700, but you don't have to use everything, you know. It's just kind of like make you feel comfortable with your design and stuff.
Yeah.
Man, your computer is slow.
I guess so. It's hard to argue with these. results. Oh no.
Oh, boy. What's your
It's fine. Like I think I'm just use SolidWorks anyways.
Well, there are some other teams that
Okay, yeah, true.
yeah, we're recording this, so we're gonna post this.
Let's see if I could figure it out real quick.
How do you not know your password?
I don't know what email I used. Oh God. Oh, okay, easy.
I'm embarrassed for you.
Why? I did it so quickly.
Your computer's gonna take about 10 years to load it in.
Oh, that's why you're embarrassed for me.
Yeah. Dude, how do you even play Tarkov with this kind of computer?
At like 12 frames a second. Oh, I could I'll post this in the Discord before I forget while we're waiting.
Okay.
I can just post it in the general. We'll just be sitting in here.
Okay. Yeah, usually, yeah, we don't really post much in the general.
Yeah.
But it's gonna be like the people who watch the videos, they'll be able to design their sheet metal parts. Everyone else is on their own.
Oh, we're almost in.
Well, look at that.
Oh Lord, I'm not gonna update right now. Okay. So to get to the assembly, we're gonna need to make some more parts to assemble. I don't really have much saved
What
in.
is salt test?
I was testing like salt annealing the 3D prints.
How did that work out?
I don't really want to talk about it. It would have worked great, but I put the temperature way too high and it just melted and ruined my cup and everything.
That's all.
Yeah, I kind of messed that one up. I thought I would have to have the temperature higher, but it just completely melted
In
instead
the
of like,
microwave, right?
no, I put it in my like toaster oven.
Oh, really? Okay.
Yeah. Dude, I thought I ruined it. It smelled so bad. Okay. I don't want to make another aluminum extrusion that takes too long. I'm just going to make a big rectangle.
Yeah, the good part about Fusion 360 is that it's all cloud-based. Everything saves to the cloud. It makes collaboration a lot easier because you can just like open it up. You can create a team in Fusion 360, and then you kind of create a team folder that everyone has access to, and you can just save your files in there. Then everyone can just access it whenever they want. You know, it's not like a Google Drive where it's like live, but you know, you'd save it and then they would get the cloud saved file and they can edit it then.
Can you show how to do that once you're done with that?
I wasn't really listening to you, Jason. I'm sorry. I don't know what you said.
Click down on your name, on the drop down for your name, Matthew Miram.
Okay.
Then you click create or join.
All right.
And then you just literally, you know, everyone has a Fusion 360 email account or, you know, their username. And then it would just basically be click next, create team. You will be the team administrator, team awesome dragons.
I don't want to say that. I'm just going to put it, I'm just going to say team. Okay. All right. Invite each member manually. That's probably what you guys would want to do if you did a team in here.
Mm-hmm. We're setting up your team. Invite me, Matthew.
Okay, I'll do that. Let's see. I think it's loading. Is this the team thing? Yeah, okay. Do you know how to invite you, Jason? I've never done this before.
Yeah, click on the settings thing or the settings of the I don't know.
Cool.
All right. Now, members and roles. It's at the top.
Oh, I see. I see.
All
I'll
right.
invite you.
Yeah, it's just Jason
Just
Babayev
Jason.
8. Yeah, at gmail.com.
That's right.
Yeah, that's right. Sending. Ooh. Let's see. Okay. Let's see if I have this invitation. You know,
I've
it's
never done
kind of
this
complicated
before.
because SolidWorks has an additional software that lets you do this sort of thing, but it's not free.
Yeah, it's not included in the license we have, so sadly, that's just how it is.
All right. Let's see. Create or join team. Hmm. Yeah, I think it hasn't updated yet, but I should be able to join yours. I've done this before, and that's how it works.
Okay.
Like,
Anything else you want me to do in here? The team thing?
no, I think thing's fine.
Okay.
I just want to go over it kind of briefly. You can look up how to do this online too.
Yeah. So the steps to making this part was pretty much identical to the SolidWorks thing. It was all like the same types of options, just different interface.
Yeah, I get how to make a part in like this. It's like it's basically the same thing, right? You just
Yeah. Doing
and
an
then
assembly is different though. You don't
yeah,
just like
that's what I was trying to
open a
figure
new
out.
file as an assembly, right? All the assembly is done in the same file. So we can come
Yeah,
here.
but you would also want to design your parts in separate files and then create a new file. And it's not really an assembly file. It's just a different file that you'd use for your assembly, just so that you can keep everything separate and the timeline doesn't get super complicated at the bottom. Because like if you
This
look
is
at the
what this is
bottom,
about.
yeah, it has a timeline where you can literally drag that little icon and travel through time, travel back in time to before it was extruded, and it was just a
What?
measly sketch. And you can edit those features just by double clicking them.
Yeah. So if I wanted to change this to like 300, I just double click that and it puts me back in here. So I can make it like 300 millimeters.
It's like it just lets you go back in time, change things, and then you can go back in the present day and be like, oh, things are changed. Like Biff is now waxing my car or something like that.
Yeah. All right. So we have this body right here. You can create a component out of this, and that's kind of how you do assemblies. You just have a bunch of different components. If I'm wrong, just say something, Jason, because I don't use Fusion 360. It's just what I remember.
Oh, so I have to pay attention. Okay.
Yeah. Okay. So we
Yeah.
have one component.
Assembly, you have to make it into a component.
And then to make another component, we could just make a sketch and make another part right in here.
Do it in a different file.
Oh, can you? Okay.
Yeah. Just so like you, and then just show like dragging it in.
I don't want to. I went in that sketch on accident.
Yeah.
So I can make a new part and bring it in as a component.
Yeah.
All right. What kind of part should I make? I can do another rectangle.
Do a rectangle, make it circle.
I'll make it the 20 by 40 extrusion.
Oh.
I mean, I'm just going to make the rectangle again, but it's going to be the same size as the 20 by 40. And then come in here, extrude it. I'll make this one just 200. Then I'll make this a component again, which would just be coming down into bodies, right-clicking the body and create component from it. Okay. Then I come in back into here. Actually, I could do it back in here. Do I need to save it? I probably need to save it first, huh?
Uh-huh. So like you see those like cubes in the top left corner?
No.
Oh, more to the left. The like above that. Next to the new file thing, the cubes in the.
Oh, okay.
And so you can just click scroll down or like click on the wait, scroll up. Okay, click on the all projects drop down. Projects by me. Yeah, it should be somewhere in there. Scroll down.
What are you looking for?
The file, these files, they're all in there.
They
Where's-
should be, yeah.
Oh, there they are.
Okay. I'll come and I'll save this one too. 20 by 20.
Yeah. Then make a new file for your assembly.
All right. It's just new design.
Yeah.
Okay. And then we can import them how? New
Drag 'em.
component.
Yeah, you can do that. Um,
I don't think that's
this is for assembly. You'd have to insert it first. So you can literally just drag it. Oh, you have to save this thing first. Your untitled.
Yeah. I don't use Fusion 360 much, so
Yeah, I think they changed the drag and drop thing in the latest edition, but it's something very similar.
okay.
You have to place it first. Oh, okay.
They're in. Okay.
And
You
then
can't just drag these, you gotta use these arrows, I guess.
yeah, you can click on the center thing and then you can drag and like that
Oh,
dot
okay.
in the center.
Nice. So instead of using mates in Fusion 360, everything is a joint. So I'm just gonna put that down. Come here, make a joint. Try and make a joint between these faces. Okay. Am I doing this right?
I think you only selected one of the components. Because it says for snap, it doesn't have it selected.
Okay, now it does.
Okay, maybe I was wrong.
Yeah.
Here, do you want me to share my screen? We can do it.
Yeah, you could do it if you want.
I don't see your team here, your input. That's weird. Here, wait, try going, click on that, click on the search icon, or no, click on people, and then invite me again through there.
Okay. I'm clicking, but I think it's loading.
It might be, yeah. Maybe exit out of your assembly, your joint.
Yeah. Okay.
Does that help or no?
No, it's not letting me type still.
That's weird. Try exiting out of that and then going again. Reopening it.
No, it does not want to let me invite you. I'm sorry. I'm not allowed to work in here.
That's awful.
Yeah. I'm not really too much of a fan of Fusion 360 for assemblies. For just doing like parts, it's pretty much identical to SolidWorks, but the assembly is a lot different.
Yeah. Here, let me share my screen.
Okay.
Hello, everyone. Can you see my screen?
Let me check. Oh, yeah.
All right, so this is just an untitled thing. Well, let me open up an assembly I made in the past. And this is for the big 3D printer that we made a while ago, and it had 3D printed like an extrusion system. And the extrusion system didn't work as well as you'd hope, but this is what our assembly for it looked like, and I made it in Fusion 360. So it was designed to use wheels And I'll show you how I did everything real quick. Let me delete all these joints. Delete, 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 you thought, delete, delete, delete. All right, so now everything's just in the assembly file. You know, nothing's like constrained. This system's constrained because it's its own assembly file that I imported into this assembly file. It's like complete assembly file. But you know, since that's kind of what we're gonna be doing, it's kind of like it's kind of what we want. So basically, I have a couple joints on these wheels. These are just spacers, so they fit correctly on the aluminum extrusion. So basically, those would there are special holes, mounting holes that I made for these. They're right here, like they come around. The way that it's designed is kind of weird, but it's how I thought to do it. So let me start with these top wheels. So I would go into the assemble thing. So it asked me if I want to capture the position because everything's been moved. I just want to do capture position. It's kind of annoying with how it does. And you can use the middle mouse button to move around, which is I think is pretty good because I don't think Solidworks lets you do that.
No, middle mouse rotates.
Yeah, the middle mouse is just to pan over, which is really nice, honestly. And you know, this thing's kind of annoying. I don't need it right now, so I'm just gonna close that. Okay. So let me, I'm in the join mode and I can click on these circles. It'll tell me exactly what I'm, you know, going. I can click on this thing and then I need to click on what it needs to be jointed to. I want it to be jointed to these inner washers right here. Because that's where they need to be secured. Okay, so I see that the way it worked is it didn't place it exactly where I wanted, but then I can move it. It needs to be moved, I think it was, yeah, it looks like it's 10 millimeters. It needs to be moved 10 millimeters. You know, it's not the best way. You just gotta make sure, you know, it's 10 millimeters. I can also do this. Just because of the way it was positioned and the way I jointed it, it put it backwards, but I can just do the joint and then capture position and then click on this side of the circle because that's where I know I'm gonna do the assembly, or that's the side I know it's gonna connect with the part that I want it to connect to. And this is how you rotate. You just click on this cube in the top right corner and you can just drag and then you can rotate wherever you want. And then boom, it's connected exactly how I want it to. And I can do the same thing with the other wheel. The one without the washer, where is that? Oh, it's down there. Oop. So I need to go on this side of it. And I can use the keyboard shortcut J just because it's easier than going up to the top. And now I just need to go to the other side. Select that. And boom. That's there now. And I designed it so that these sort of can slot in because I wasn't exactly sure the distance they should be, so I knew that I can get it approximately right. So I just designed them so that they can slot in. I use the J for joint, and then I can click on that face, that washer, or a spacer, and then I can click on like I can click it right here, and it should. Oh shoot. Did not work how I thought. And then if you ever get lost, just click on the home tool and then it'll home you. I think this interface is easier than SolidWorks, and the pan makes it easier. I don't like the assembly of components
It's
that
really
much.
just whatever you're used to.
Yeah, I just think that this is just kind of easier. Okay, so I know that this washer is jointed to that other thing. So as soon as I like place it down, it should come with it. But there's also a rotate tool. I would have to just click on the axis I want to rotate it on, and then it'll show me the ability to rotate it. Oh, it's not really showing me though. It's weird. Maybe it's because the way I constrained it. I forgot how I did these. Maybe I just did the face. Yeah, you can do faces too. Oh, I didn't click on the joint command. Oh boy.
Yeah, it took it out of there. It's just because you deleted all the other joints, so it's not connected to that anymore.
No, I think it is still connected to that, but it's just like not right.
Uh,
Oh, it's because I selected it second. Okay. But as soon as I place it, everything else should jump to it. And you can just move where you're jointing these things. And if you want to get like closer, you can get
you can just type in precisely where you want it to be.
Oh yeah, you see, as soon as I place it down, everything jumps to it. And then I can edit that joint by clicking here, and I can edit that value. Wait, finish position. Yeah. You know, Solidworks is probably better for something complex within assembly, but yeah. Oh, why did that one jump away? The wheel I had on there before. Okay. Whatever.
Yeah, but if you ever run into any trouble with your like assembly or your CAD, you could just ask us and we can do what we can to help you.
Oh, I see wait, how did I join? I don't think these are, oh, they were never jointed, Matthew. I just never did it.
Oh,
I just placed them where I knew they needed to be. Wait, no, that doesn't seem right.
yeah, I don't know. You did this a long time ago. I'm not gonna be
I
able to
did do this
remember.
a long time ago. But basically, I just made sure that the spacing of them aligned with the aluminum extrusion perfectly, and that's something I can see right here. Like they're not intersecting with each other, which is just something I had to make sure it was doing. Yeah, and you know, it's the same thing with importing bodies. It's kind of the same thing. You just got to get used to it. Yeah, like everything here is constrained on it. Yeah, I don't know why those joints. Maybe if I exit out and don't save. Because I'm pretty sure they were constrained at one point. I guess not. Yeah, but I also have the extruder assembly right here. Just that. You know, like I have a joint right here with the stepper motor. You can just click on it and it shows you like where it is in the timeline when I did it. You can see I have all the parts in here, and I just drag and drop them, and then I can import them. You can also mirror bodies in Fusion 360. If I were to go to the mirror tool, the good thing about SolidWorks, it has a search bar. Oh, but here's the sheet metal tool.
Yeah, it looks like it's just
Oh, yeah, it looks like it's.
similar.
Yeah, I've never used it either. Yeah. So modify, it would be, I think where's the mirror? Oh, here it is under create. So if I go back to that other assembly file, go to create mirror, I can mirror this object. I guess I would have to change it from type to components because it's currently component. Then at mirror plane, I can select this plane.
There it is.
There it is. Then I can just drag it, and then I can joint it using the J capture position. That, yeah, it's really annoying with the capture position. You can't really get away from that, even though, like, you know, you definitely never not want to capture the position.
What does it mean by capture position though?
Here, I'll show you in a second. So I can just click on the circles. Oh, click on the wrong thing. Okay. I can just unclick that and then click this.
Since you clicked the same thing. Oh no, you're good.
Yeah, I clicked it right this time, except I think I clicked on the wrong circle. Okay, so let me exit out again and click this one. Okay, but now I just need to move it. And if you zoom in, it'll give you like it won't snap to like small points like that, and then I need to move it. Wait, shouldn't those circles be right? Oh boy. Yeah, if you ever get lost, hit the home button. Oh, I guess I never need. Oh, it's backwards. That's why. Okay, I need
It's
to.
fine.
Okay, so let me show you what happens if you don't capture position. Let's say I move this here, then I want to do the joint. If I press continue, it will just like move it back to where it was originally, like before I ever touched it.
Oh.
It's pretty annoying, honestly. It's like you never really need that. There we go. And now it's in. Yeah, I never even bothered modeling this in the assembly file because I knew like if I did one side, it would be right for both sides.
So did
And
you
even
like model it, like model the holes threaded, or did you just?
no, I didn't because I wasn't getting this machined. I was actually 3D printing these parts.
So did you use screws though? Like, how did you screw
Yeah.
it in?
There's just room for nuts on the other side to sit.
Yeah.
Okay.
Yeah, so this is like a bearing. This is like the gear, represents the gear of the motor. And I pulled the motor, the NEMA 17 from GrabCAD just because it was easier than designing my own. More accurate too. Yeah, I just made sure the holes align. That's the biggest part. And the holes are big enough to fit like the screw that would thread this.
Yeah.
That's an important part. I also had to make sure, like, if I click on this, it underlines this component, so I know that's the one it is. I can click on the eyeball tool, and then I can not see it anymore. And I can sort of like look at what's going on behind it. You can do the same thing in SolidWorks. We didn't really cover that, but you can do that in SolidWorks too.
Yeah, it could be helpful sometimes if there's like a part that's behind or underneath something.
Yeah, like let's say I want to see this, but I don't want to see the component. Now the NEMA 17 is in the way. So I can just click the eye tool and then I can see how the extrusion system works. Like that's the gear, that's the bearing, and then there's a spring that goes right here. It sits in that hole right there, and there's a hole on the bottom side of this one, like a little indent. I mean, not a hole, but like an indent. And so basically, the spring will sit in between those two pieces, and it will push it up, and then it will push this thing against the gear, the bearing against the gear, and so that will just pinch the filament against the gear, and so that when the gear turns, it pushes the filament down. Yeah, and the filament gets fed in through the top right here, this hole. So there's a little gap right there, but the spring would push it and close the gap.
Yeah. Instead of designing like another custom extruder like this for the printer we want to design this time, we just decided to buy the Hemera one
Yeah.
because it's just capable of a lot more than like what this one was, for example.
This one, a lot of art.
Yeah, I don't know. It's especially like some of the 3D printed parts were kind of close to the hot end, and they do a little bit of warping.
Yeah,
So
especially this purple put this purple bit. If you saw in the assembly file, it held the E3D V6 heatsink.
yeah,
So basically,
so
this is the part that heats up really hot, and this dissipates all that heat before it goes to the hard plastic area. And sometimes it didn't dissipate enough heat, and then this purple bit right here would warp.
yeah, so it's just nicer to have one that's not 3D printed. You don't really have to worry about that. You can get to higher temperatures, and it's just easier altogether.
Yeah, you can use Control Z in here too. And I just had to make sure there was enough clearance between the wheel and the motor, and there was just enough clearance for me to be like, yeah, it'll probably work. And it did work.
Yeah, I think that's unless we're like forgetting something that we wanted to go over.
Yeah, I mean you can always change the appearance. That's not really a big thing. You can also insert decals if you want. You know, a lot of the stuff, like, if you think it's possible, you can just look up a video on how to do it.
Yeah.
Yeah.
All right, well, thank you for coming.
Yeah, no problem. Thanks for teaching me all this stuff.
Yeah.
Yeah.
If you ever have like any questions that while you're modeling something, you just ask.
Yeah, I'll hit you guys up.
All right, well, thank you. We
All
will
right.
end the meeting now. If I can
All right,
figure out
thanks. See you guys.
See ya.